This is our presentation on our move from the data center in Laverne, Tennessee to Google Cloud and our design and implementation of a high availability solution.
I'm Allan Mason. I'm the sole MySQL DBA for the point of sale system for Advanced Auto Parts CarQuest stores, the largest retailer of car parts in North America.
I'm Carmen Mason. I work at VitalSource Technologies. We're the world's largest ebook company. Most college kids have used a book in our format, VBK. We have learning software from kindergarten to higher education.
We'll cover our current infrastructure so that you have a decent idea of what we're working with. We'll include our high availability requirements per our contracted SLA. Then we'll review solutions to help manage our traffic and topology managers and tell you what we finally settled on. We'll wrap up by sharing with you our current plan for both infrastructure and failover.
So let's start with our current infrastructure and failover solution that we have in our data center in Laverne, Tennessee. Before I started at VitalSource, we were boasting 6 hours of downtime a year. Within the first year, this was down to 20 minutes, sorry. And then in 2016, our downtime for the entire year was 7 minutes. When our CEO first asked me how, I told him it was my ninja skills. And this is how we did it.
And she stuck with that. She didn't explain it to him either. We use MHA. Our current existing solution before the cloud was to use MHA with MHA-Helper. We have multiple application servers connecting to the CNAME of the database server, which is set to the virtual IP address that MHA-Helper is managing for us. This solution provides us with saved binary logs when possible, differential relay logs to update all the slaves, and notifications of the decision that MHA has made, as well as virtual IP handling. This solution has been really working well for us.
So, like Allan said, we use MHA with MHA-Helper. Most failovers finish within 7 to 11 seconds. The most up-to-date replica is promoted to the master. Virtual IPs are handled with MHA-Helper. Most of our applications are completely unfazed by the brief amount of downtime because of message queuing. The remaining slaves are automatically assigned to the new master. And then finally, we get an email that notifies us of the decisions that MHA made during the failover, such as who the new master is.
In our current infrastructure, our applications have separate databases on the same database server. So we're sharing the database instance. This shared architecture obviously comes with many of its own issues. This makes some types of maintenance and infrastructure changes more of a challenge. Not to mention the problem with noisy neighbors. So if one of our other apps/databases gets a little busy, obviously it impacts the other applications. Obviously not super desirable. Our infrastructure team also can't be the holdup. When things need to get done, we need to make sure they get done. We need to be ready to move the database with minimal downtime to production, obviously. This, among other reasons, such as the noisy neighbors, led us to separate the databases, obviously, out onto their own instances, their own servers.
Once we move. So this is the inspiration behind our talk today. May, 2 years ago, in the HipChat panic room, we get fire alarm at 1 Ingram. The UPS room is smoking. There's a smoking UPS that led the fire alarm to go off. The next thing we knew, we were being told that we needed to stand by to switch to DR. There's a possible fire in the data center. This is actually a photo of the front of our data center, and this is actually firemen with the leaky hose going into our data center.
I mean, think about it. Do you guys want fire hoses going into your data centers? I don't think that the servers would have liked that. Thankfully, they didn't turn them on, but it was pretty scary there for a while. This obviously moved up our timeline for migrating to the cloud, which up to that point had just been a circulating, discussion. Let's review some of the requirements for a new solution, as well as some of the issues we wanted to overcome.
All right. So what do you think? How many people here are using Amazon? Okay, and how many people are using
Google
Microsoft?
Cloud?
Google Cloud? Microsoft? Okay.
What about
So-
local data centers?
Yeah.
So mostly local data centers.
Or a mixture, actually. Some of the people are using kind of both. That's where we're at right now.
Hopefully you guys have the Halon gas fire extinguisher systems in your data center instead of like the fire hose solution. But,
Yeah, we have a shared infrastructure, a shared data center, so we don't make those decisions yet.
So we chose Google Cloud for a few reasons. First, and really the biggest reason, was Amazon was a competitor for us. They're a competitor to our ebook distribution business, which is our side of the business for Ingram. Second, Amazon seems to be more expensive than Google Cloud, though even with a recent price drop. But really, to be fair, it's hard to be sure. The number of options and everything else is very confusing. We've read a lot of discussions on both sides of the fence arguing which one is actually cheaper and so on. We've compared instance types as closely as possible, trying to compare apples to apples. But really, it's tough. I mean, you've got the reserved instances on the Amazon side, which obviously cuts the cost significantly. But then
The
you're
sustained
losing...
use on Google that drops it by 30%.
Right, but then the problem with the reserved instances too, you're paying for 3 years, you're losing that potential capital and interest that could have gone towards other infrastructure investments. So it's a very complicated decision. At the same time, on Amazon's side, they've been doing this for a while and have a lot to offer, but Google also seems to be nice and speedy for us as well. Our performance has actually been surprisingly pretty good.
So the short of it, it was a difficult decision for us to make. Our requirements were to move all of our existing applications and databases to GCE. The boss man's mandate is that infrastructure cannot be the holdup. We must have things ready for the developers to move into. The initial request is to accomplish this in 1 year. We knew realistically 2017 was easy for us to do. I went into surgery in the middle of July, and when I came back August 1st, my boss told me and one other team member that we had less than a month to get this completely vetted, or our current solution, or decide on a replacement for MHA with MHA-Helper. Tested, documented, and the care and feeding that we could give to other people in case they had to maintain it.
So we had a mandate to do things properly, which is always nice. It meant, on the other hand, though, quick adoption of a lot of new technologies. We started using Kubernetes, Docker, Jenkins, all things Google Cloud and more. These were all brand new for us in a very short time frame. There was a lot of learning, trial and error for a small team of 3 sysadmins, 1 DBA, and 1 part-time unpaid DBA. The pressure from the business side was also very intense. After all, I mean, think about it. If it's easy to ask for, then it must be easy to do, right?
We had a few known issues that we had to keep in mind when we were developing our plan. The initial interest was to use Cloud SQL, which is similar to, which is a Google Cloud managed database solution, which is similar to RDS. It has a few issues. There was an assumption that second generation HA with Cloud SQL would replace our current HA solution. It really doesn't. This is specifically for if a zone goes down, and then you have a replica whose sole purpose is for that failover. It can take up to 5 minutes for them to realize that the zone goes down, and then 2 minutes to actually do the failover. This means a 7-minute downtime, which for us was way different than what we have right now.
And really, if you think about it, this is just for the whole zone to go down. This is not server by server basis.
Yeah, this isn't like a rogue dev that's crashed your server, or anything like that. Also, it's not Percona server. We're entirely a Percona server in-house. This only offers Community Edition and Postgres in beta. So we decided we're going to manage MySQL and GCE ourselves because Cloud SQL does not meet our requirements.
But really, if we'd been on Amazon, it probably would have been a similar situation. We probably would not have used RDS. We probably would have gone with EC2 so that we can better manage things ourselves. Yes, sir. Correct. Correct.
Right.
That's with the Cloud SQL.
So he asked, just to be clear, if the primary has an issue, it doesn't actually fail over. It's only if the zone goes down, and that's correct. Right.
So as the Google guy is telling us, that's a solution, obviously, that they're working on, and understandably so.
So there's an API call that will trigger a failover.
Okay.
That's cool.
There is not.
So there's an API to help assist with a manual failover. But I mean, obviously, that could be scripted and.
Yeah, obviously, you would basically be building half of a failover.
Sure, sure. And then use something that you've scripted up to wrapper around it.
Oh, that's good to know. I have an IP address.
Yeah, it's from one of the. So we couldn't use our current failover solution in Google Cloud. We wanted to, for one, use the latest OS, so we moved to CentOS 7. The MHA-Helper, though, one of the big parts of our current in-house solution, which is a wrapper by Office Tariq, has no support for CentOS 7.
At the time that we were doing the evaluation.
I'm not sure if it's been fixed or not, but the GCE also has no VIP support, no virtual IPs, something that was a very big part of the whole point of having the MHA-Helper, because it just automatically took care of it for us. This was depressing, obviously. So our solution using MHA and MHA-Helper was something critical in our current data center. Like I said, it saved our bacon so many times. There was times where we barely even realized it failed over until after it was done. That happened quite a few times. This quick, solid failover gave the business so much confidence, they actually started charging for 3 nines in their contracts with the customers. So it was back to the drawing board for us. But on a positive note, this gave us a chance to start looking at some of the newer solutions, see what everybody else was doing, and figure out what was the best way to do it.
Our personal requirements were to at least reach the current proven uptime with hands-free automatic failover. We are now contractually 3 nines SLA. The applications need to somehow know just which database to chat up in the event of a failover. And without the virtual IP support, we need something to manage that access for us. When the master tanks, the slaves need to be synced up with the most up-to-date slave. The uptime is really king with our company, although we want to lose as little data as possible. It would be nice if the slaves were also automatically issued the change master statement to point to the new master. And lastly, we want to make sure that the old master is put in the corner where it can't do any harm. Like I said, I've got a ninja reputation I need to uphold.
So we knew we didn't have virtual IPs in Google Cloud, which our solution relied on in our data center. But MHA is functional without it. The applications just needed a new way of knowing how to find the new master. Thinking that this left us with a topology manager, but nothing to communicate access to the apps, we decided to split this into 2 problems. Now we were going to look for something to direct the traffic from the applications, as well as something to handle the database replication topology.
So how are our applications going to know who to chat up?
So the solutions that we reviewed to control traffic from the applications to the database were MaxScale, HA-Proxy, and ProxySQL.
We set up test instances with MaxScale as managing the traffic and Orchestrator as our topology manager. The initial tests were a dream. However, comparisons between MaxScale and ProxySQL at the time showed that MaxScale doesn't seem to scale well. Just as we began to set up our own test, MariaDB announced the BSL license for MaxScale, so we moved on.
In fact, the scaling for MaxScale seemed to have a problem as soon as you hit 6 threads.
Based on
So
research.
very low numbers where it started to have a problem, it seemed. So we looked into HA-Proxy. We had a lot of in-house experience with it. We decided after looking at MaxScale and ProxySQL that we would prefer something that would give us a little bit more additional functionality to MySQL. Something written specifically to understand the MySQL protocol.
This led us to ProxySQL. It's written specifically for MySQL. The author, Renee, is quick to respond to bug reports and commits, which is always a plus. It does exactly what we need it to do. It monitors our existing topology and quickly recognizes any changes to it. ProxySQL also gives us avenues to other functionality that we find extremely intriguing, and we're going to review after we move. The features that we find the most interesting are rewriting queries for when our developers just completely fub and they need to fix their code, splitting writes to master and the reads to the slaves. Load balancing during school registration would be huge for us, for our bookshelf application, and during finals week for our notes application. Finally, query throttling for when we have those universities that dump all of their registrations on us at once.
And really, these features were huge. Like, they seem underrated, but like the ability to rewrite the queries, like that's huge. We're always getting devs that are giving us some boneheaded query or some completely new query that doesn't have an index.
Those are fun. New project, new indexes.
Yeah, something that either was converted from a few seconds queries to potentially hours and are sucking down the CPU or memory or whatever. This gives us the ability to either block the query completely, dump it into dev null, or rewrite it on the fly.
I like dev null.
Installing the ProxySQL is simple enough. We can find it in the Percona repo. We decided to install it in the container along with the application. This is known as the tiled approach. This gives us low latency between the application and the ProxySQL, obviously, because they're on the same host. This is known as a tiled approach. This gives us minimal points of failure.
All right, I gotta say it. Before running ProxySQL, make sure that you change the default admin credentials because they're just setting there admin, okay? Our configuration file is mounted as a Kubernetes secret because it contains this sensitive login information.
We're using the remaining default configuration settings in ProxySQL, except for we changed the MySQL monitor ping interval from a minute to 5 seconds. This is to more closely match our MHA monitoring solution that we're using in our data center. We also decreased our connect retries on failure to 5 from a default of 10.
All right, then you create the monitor user for the database and allow it to view the replication status on a server. I would suggest being specific. It only needs replication client grant. The monitor watches for the read-only flag on the server, which is being handled for us in the config file. The writers are host group 0, and for us, the readers are host group 1.
The ProxySQL is actually really quick to catch the flipping of that read-only flag as well. As I recall, the number was about 500 milliseconds.
It was low.
For it to fail over and make the changes to
it was
the
acceptable.
host groups. It was really good. So now we have the replication topology managers.
This is going to make us cry. Since we needed to reevaluate how we're handling our traffic, why not make sure MHA is the best option? Especially since we are not able to use MHA-Helper wrapper. This gave us a brief chance to look at Orchestrator. We really just wanted to be that database administrator underneath the desk that's like dragging and dropping masters and slaves all over the place. But seriously, it's an amazing product.
We're planning on using it in Q4 of this year. We just needed more time to test it. We're currently testing it in dev. The other reason we didn't go with it for the first go-round is it doesn't handle the differential relay logs, and we weren't sure we could do without that, at least at first. We had so many new things that we were doing in the first go-round that it was just one less thing to not worry about.
Now, we were asked just the other day, why not MHA? And, I very nervously babbled for a while. But Alan
Said
and
how
I talked
difficult
about
it
it.
is to set up and everything else.
So Alan and I talked about it, for a little bit, and I talked to my team a little bit about it too. And our why not MHA is actually pretty easy. The last change that was made to it was February 3rd of last year. And before that, it was another year before anybody had changed it. It's not being currently maintained, it seems. I like the idea of having something where I can either, suggest changes or check in changes or complain to the person that's maintaining it.
And thank you to Shlomi. The Orchestrator is Shlomi very heavily maintains Orchestrator.
Yeah.
It's very actively developed. It's a great product. I mean,
Renee's been so responsive to the changes and the suggestions that we've made.
For ProxySQL.
And it's kind of got us thinking, We have a few years experience in-house with MHA, however. So we've decided right now, with all the changes that we have, to play it safe. It's complicated to set up, yes, but once it's automated, it's easy to use. It's proven. And at the time this decision was made, it's the only known solution to bring all of the replicas up to date with the latest slave.
So this is what we came up with for our MHA solution. We have 2 instances in the East region, each in a separate zone, and 1 database in Central in case the East goes down in some sort of fiery inferno. Because, hey, we've already had it happen once, right?
Yeah, that was Central.
It's important to note that for Central to be master, though, the failover needs to be manual. We've done this by choice. We currently have set the Central database to no master in MHA so that it does not get chosen as a possible failover. This is because there's roughly a 10-second latency between East and Central, and obviously we would prefer to go with another East database server before we go with Central, just to eliminate that extra latency.
So to set up MHA, you need 1 manager node, you need 3 MHA nodes. You install a few Perl dependencies, you install MHA node first, including on the manager. You install the manager. And it's important also to note that it assumes that it's being ran as root.
So MHA uses SSH to monitor the nodes and to apply differential relay logs. Obviously, all of its communications back and forth. Passphraseless authentication is recommended here. Set this up and then in your my.cnf, make sure you set read-only. Always set your databases to read-only if you're replicating. You don't want one of them going down temporarily and then coming back up thinking, oh, hey, I'm still the master. You can write to me, and then you've got split brain. So it's just an easy little extra to help fence off something that may have gone down and rebooted for whatever reason. You really probably want to bring that manually back in without just letting it start accepting writes. Also, log bin needs to be enabled on any of the candidate masters. If there's no slaves with log bin set, automated failover by MHA will not happen. Replication filtering rules such as bin log do DB, replicate ignore DB, etc. This needs to be the same on all the databases. And you need to preserve the relay logs. MHA needs them. They recommend manually purging the relay logs. They even provide a script to help with this.
All right, so when you first start up MHA, what happens? It runs a sanity check. It reads the configuration files. It pulls the servers. It tests out SSH. It checks the output directory. It checks the bin logs. And if everything is good, it just sits there and listens.
So what happens during a failover? You'll get a warning in the error log, something like got error on MySQL select ping. The MySQL server has gone away. If it can access the drive of the master, if the OS is still there and it's just the database that's gone down, it'll pull the bin logs from that server and save them to a directory on the manager node. Otherwise, it'll pull the slaves to figure out which one is the most up-to-date, and it'll pull the relay logs from that slave. It'll also check 4 more times to make sure the master really isn't there. because anything could happen. It could be a hiccup in the networking. The master could have just gotten really busy. Anything could happen. So when it does the failover, it polls the servers, see who's still up, who's down, and then it does the phase 1, which is the configuration check. This is really almost identical to the initial startup for MHA, where it basically sanity checks everything. Phase 2 is the dead master shutdown. MHA allows you to have a script, a custom script that you can run on the master that's gone down. In case you want to do something, tweak DNS, anything like that.
All right, so how do we get all these great ideas to work, including moving the databases up to Google Cloud?
We had some interesting challenges here. We found out initially that our network has had some problems, especially really uploading files outside of our network. When we first started trying, we were getting a few kilobytes a second on the file transfers, and one of the databases was a couple of terabytes. It's important to note that we share our network with our parent company, Ingram, and with all of the sister companies. So really, somebody else is managing the network for us, so it's not always easy for us to just go in and fix it. And unfortunately, they were saying, well, we don't see a problem.
This led us to a lot of iterations before finally deciding on how we were going to move the data. Some of them were just insane. Late night, brilliant ideas. What we need to do is upload large databases and then replicate them back to our data center with minimal slave lag, right? Until we're ready to switch the master up to GCE.
Here on this slide, we actually had one of those brilliant late night ideas. Since going directly from the source server to GCE was so slow, we're like, well, heck, we've got a faster connection to DR.
Dedicated pipe.
Let's send it to DR first and let DR upload it to GCE. So this was kind of
one of those harebrained ideas.
But at the same time, we needed to test everything. Yeah. Like, it was originally going to take about 10 days. So we needed to try everything we could.
This was going to take 10 days, and this was the fastest that we were able to do it first.
So to move our databases to GCE, we needed to rethink our typical slave within OBackup EX. The VPN wasn't stable enough to use that, to support that concept. So our network connection out of Laverne wasn't fast enough and shared with too many others. We attempted to direct connect to GCE, but this was also limited by our pipe out. The final solution included extra backup with Aspera to do the move. Our boss had bacon-saving experience using this product at his previous company, our sister company, and was able to get a trial license for us. It is important to note that Aspera is a cost item. We found that Aspera really did the trick, though. The transfer speeds jumped from a few kilobytes to very high megabyte speeds, very high speeds. We were able to stand up, in the end, a 2 terabyte slave in less than 8 hours. That's starting from the backup through the upload to the final change master for replication. The transfer time, just the file transfer, went from over 10 days to under 3 hours.
So we used extra backup. We included the slave info. You saw on the herding cat slide, we have multiple databases on this. So we specified which database we were going to back up. The backup was made to a local directory. We use this to compress the data as well. It creates a larger compressed file than compared to, say, pigs, but it uncompresses faster. We use XBStream to create the backup as a single file. This allows us to skip the bottleneck of tarring and zipping the directory, which would have also created extra writes on our multi-terabyte backup. You do need to install QPress and XBStream on the destination, though.
Like, that was an important part of also the one of the optimizations, was using the OBackup EX and having it do the compression. That really made a big difference.
And bypassing tar.
Because again, it's a multi-terabyte file. The tar and the pigs compression would have been extra writes to the disk. So
This was an accident.
this was a fun story. At one point when we were trying all the different possible solutions to get the data up to GCE, we tried using, I mean, it's a multi-terabyte file, right? So we tried using GSUtil. They have a copy function to upload the backup. This was going really, really well. The throughput was amazing.
Oh, it's so fast.
And
crazy.
so, you know, once we got it kicked off and started, we were waiting. We noticed a couple messages in the network panic room. And then started to be a lot of messages. No big deal.
Yeah.
It's not us. It's
And then,
networking.
Carmen, are you doing anything?
So, seems the network's down. I wonder why. Apparently, we had sucked up every last little byte of bandwidth on the network.
For our parent company and our
And
sister
took
company.
down everybody for a little while. I mean, thankfully, it was easily fixed. We just killed the transfer, but...
It was going great until we had to kill it. All right, so we used Trickle so that we could throttle this.
Now.
Yeah, now. So Trickle controlled the speed of our transfer. We used it along with GSUtil, and as you can see on the bottom, I've got the whole command there. But GSUtil will resume the upload if it dies somewhere in the middle.
Which
And
was
then-
important for us because of the VPN stability issues.
Yeah, the lack of stability. And then we use Trickle to make sure that I'm behaved. Initially, we filed the smaller databases. Initially, we copy up to Google Cloud Storage, which is similar to the S3, so that we can preserve a backup.
So for smaller databases, we were able to move them from the bucket to the instance. For the larger databases, we used Aspera to directly send them to the new slave instance. This was the fastest solution we wound up coming across. We're using pass-phraseless SSH to move the file. We're specifying the minimum and the target speeds for the transfer. And to improve the throughput, we also turned off encryption. This is some of the parameters we used for the transfer.
And then again, our final command at the end. Also, for our failovers, we're going to need to make sure that we have minimal slave lag. We're using PT Heartbeat to help us with this, to monitor the slave lag instead of seconds behind master on the slave status. The SQL thread, the SQL slave thread might be caught up while slave IO thread is still chugging. So you might see a 0 seconds behind master, but you're several relay logs behind. PT Heartbeat is easy to set up, and it's even easier to use. This here shows a basic use.
So the idea now is to run a database replica in our GCE production environment. Applications that can run parallel builds in-house are encouraged to do so that the data can then be compared by the analysts and the QA team. Once we're comfortable with the replication and monitoring with PT Heartbeat and the applications are ready, we'll fail over into Google Cloud during a brief scheduled maintenance window. We were expecting around 5 minutes of downtime, but of course, like Scotty on Star Trek, we're going to be telling them like 20 or 30 minutes because, I mean, really, things happen, right? All the best laid plans, so it's good to be prepared. I've got it, thanks.
All right, so our switch to GCE master. I'm sure everybody is familiar with this already. So what we're going to do is we're going to stop the writes on the current master. I did this in screen because network, right? We do the flush tables with read lock, set the global to read only, keep the window open, set it aside so that I don't mess with it and accidentally close it. Our application team, at this point, it's one of the 3 sysadmins that I have that are helping me, will handle the application switching in the background. They'll handle the DNS, and they'll make sure that the clusters are already set up and waiting. They've got the secrets already. So I'm going to do a stop slave on the new master, and then I'm going to sit there and wait and make sure that, I don't have another event. And then I'm going to do a stop slave after the show slave status, And then I'm going to do a stop slave and a reset slave all. I'm going to stop the service on the current master, and I'm going to tell my systems administrators, go. They're going to make the DNS changes. This is, of course, we've reduced the TTL in advance, so that
So
we don't
that-
have any issues.
Yeah, because if you leave the default TTL, obviously, the time to live for the DNS, if you just leave it at high numbers to reduce, polling on that server, your various clients will take longer to realize that,
We've been bit by that
the
a few
DNS is switched. So, as we get closer to the maintenance window, we drop that TTL down.
Right. So we're going to make the DNS changes both on our local DNS servers, but we're also going to make them in Google. And then we're going to start up the MHA manager because we've not been able to run the MHA manager while the slaves are pointing back to Laverne. Okay, because MHA is only handling the servers that are up in Google Cloud. So finally, let's move on to our final infrastructure and failover solution.
I guess we put that one slide a little early.
Just a little.
So we have ProxySQL on each application server with no silos. This is giving us no single point of failure. It's scalable. I mean, really to a point. Eventually, if we have like 1,000 servers, 1,000 application servers, we probably don't want ProxySQL establishing a pool of, say, 10 or 20 connections each times 1,000 to a handful of databases. So at that point, if we get to that point, we'll probably do a ProxySQL multiplex topology where we have the ProxySQL still on the application servers, but actually talking to a smaller set, middle tier of ProxySQL servers of, say, 3, so that we scale down the number of connections on the final database cluster. MHA is, of course, still part of the solution. It's saving the binary logs as well as handling the differential relay logs. And we have notification in both HipChat and email to let us know everything has happened.
All right. So what a failover looks like for us. We've maintained a similar failover time of 10 to 20 seconds, so I still look really good. We'll be testing with lower polling values to see if we can shrink this down to something more closely to what we're at right now, because we've kind of doubled our time. MHA still determines who's going to be the master based on the most up-to-date replica and where it's located, whether it's in East or Central. ProxySQL will then discover the new master based on the read-only flag being turned off, at which point the new master is added to the writer host group, also leaving it in the original reader host group. MHA then slaves the replicas to the new master. A change master statement is logged for me so that I can update the old master once I'm done feeding it into submission. Finally, we're notified in HipChat and emailed all of the decisions that were made during the failover. I've maintained my ninja status.
So some of the new issues that we're running into. There's roughly 10 milliseconds of latency between the regions, which means that the master and the primary read database instances are in the same region as the application's Google cluster engine, all in East. In the scenario where we have a catastrophic failure again in the East, we also have the database node in Central. We would set this slave to, we've currently set this slave to no master in the MHA config to prevent it from becoming master automatically. We need to manually fail it over. That sounds like a redundant slide, I'm sorry.
But it is a serious issue. 10 milliseconds doesn't sound like a lot unless you're in our world, and then it's really a lot. Every time we're running mostly Rails application. Rails makes a lot of extra connections to the database. Are you there? Are you really there? What databases do you have? Can I see your tables? Are you sure those are your tables? What are your fields? Like, it's nonstop chatty with the databases, and 10 milliseconds adds up really fast.
Yeah.
All right, there's our contact info.
So what do you guys do? How do you guys solve these type of problems?
I'm really curious to hear about the performance of all this, because actually I'm sort of thinking of doing exactly the same thing. I think we already have solutions in place for a lot of the topology and sort of management issues, but I'm really curious about performance. Like, what were you going from? What kind of instances are you going to? And how is performance compared?
A large majority of our instances that we're using right now for our databases are the standard 32, N1 standard 32. I have one database that we set up recently with N1 high mem 32 and N1 standard 32 because we were worried about performance issues.
So we originally overdid.
Yeah.
We originally overdid the instances, and then we scaled them back when we realized that the performance was so good that we could go with smaller instances.
We were worried about having CPU issues, and we didn't. We beat the snot out of them just this past week. My team, while I was here, beat the snot out of the standard one to see if they could slow it down, and it was at 7% CPU almost the entire time. Unfortunately, I don't have the exact statistics. When I asked them for it, they were like, we didn't save those.
We wanted to do a sysbench test, and I'm sorry we didn't get it. The one server, bare metal server that we had in the data center that we were going to use for the comparison went away. We had a prod emergency, and obviously that took precedence over the sysbench testing.
We do have applications that are running parallel builds. Like, for example, we have a catalogs application that stores the books that our publishers give us for the schools. And it's a pretty intensive operation because initially they were rewriting the databases, the tables entirely, and it was one catalog per company. And they were doing this every night. Comparison apples to oranges, right? From our data center in Laverne to what we have in Google Cloud. It's actually more performant in Google Cloud. Our builds that take 11 hours at home are taking between 5 to 6 hours in Google Cloud. So it's much better.
It doesn't make sense, but because typically when you move to the cloud, things get slower than the local servers with SSDs. I'm guessing
we're using Fusion IO cards on those too, on the ones that we have in the database.
Maybe the CPUs. Maybe the CPUs on the Google servers were newer, better, not sure. But really, it seemed to be faster. There was 2 apps that we were testing. And
running on SSDs on cloud or on?
We're running on SSDs on cloud. Our operating system is the
Persistent SSDs?
Yes. Yeah. Persistent SSDs. No.
So it seemed to be better.
Yeah. It does seem to be a lot better. Yeah. Like I said, the only issues that we're having right now are the networking between the zones. It's the only issues. And it would be awesome if the projects could talk to each other because we have a disaster recovery project and we have a production project. And there's communication. Can they?
Recently added something about that, about being able to set up network between separate Google Cloud projects.
That would be amazing because, like I said, our disaster recovery is already up there, and it would be great.
So currently, we've got 2 of our apps up in prod in GCE.
We have 2 of the old ones up. Yeah.
So obviously, we're going to continue pushing the rest of them up as the apps are ready. Some of the apps aren't quite ready yet, so as they finish up whatever tweaks they need to make, we'll push them up.
But we're ready. The developers aren't ready,
yes.
Right? Because our bosses.
Which was what we needed, right? Because you don't want to be the one that everybody's pointing the finger at.
No. So any other questions? Any other advice?
Thoughts?
Help me. Yes, Jesse. All for it, because it's expensive. She's saying she's got a way to get around Aspera. Here. You can have mine.
No. You run the risk of tapping.
So I had to move like 5 tier to AWS.
Okay.
RDS, and what we wound up doing, and laugh and cringe, is we had an array of servers on AWS and we moved 5.
Okay.
Then we went on the original server, took our actually snapshot, and we went through it with the threshold. Any file over X got split up in multiple pieces.
Right.
We had an LFTP running multiple to put. We also had parallel in there, divvying up the files to each process.
So you're using the composite parallel in GSUtil?
Parallel to watch multiple LFTP with multiple threads, also 5 servers in the data center. And then I had a nice little dirty bash script that basically sat there and waited for the file to be completed, and I put it on one server and put it all back together. So I got it.
So you transferred it on multiple servers, pieces onto multiple servers.
Multiple servers from
Oh, that's
You load balanced it. That's awesome.
that's,
It was nasty, but it didn't work.
That's
oh,
awesome.
that sounds like a great idea, actually.
Yeah, because
So-
this Sparrow, like I said, it's a cost item and it's not cheap.
It's very good. I've seen people use it.
Yeah. Thank you. Yes.
We also Rails have running ProxySQL on multiplexing the connection between us. By default, those off ProxySQL won't work because active record will set session variables and ProxySQL on multiplex doesn't set those variables.
Right.
I just thought command viewers of ProxySQL would set variable hash.
The active record.
And it's supposed to say multiplex. So the big for us is that
Yeah, that's important to remember. Thank you.
Can you
makes-
repeat that? Do you need?
Yeah, he's saying that with active record, all of the little queries at active record, basically, right? All the,
when it initiates a connection, it sets some session variables.
yeah,
And ProxySQL won't multiplex because it doesn't multiplex variables by default.
Right, right.
So in the new version of ProxySQL, you can write a variable, match that, once it's multiplex.
and 1.4.
Yes.
Yeah, we're using 1.3 right now.
So I've got around that myself, so I know it works. Around that.
Yeah, ProxySQL just released version 1.4, what, I think a week ago? Something like that, yeah.
That's really important to
And
remember.
it seems to have a lot of new nice features, including better performance, among other things. Has a lot of good features. Anybody else?
Hold on a second, I'm writing down what he said. Okay.
Well, I hope you guys liked our lecture. I hope it wasn't too dry. This is our first time lecturing here, so
Oh, excuses.
we were nervously excited about it. Thank you, guys.
Thank you.